Hello students! In our previous video, we learned that cumulative frequency is the sum of all the previous frequencies up to the current point. It is also termed as the running total of frequencies. Students, a table showing the table of cumulative frequencies is called a cumulative frequency distribution table. In our previous video, we asked you some questions. That from the following data, can you tell me how many students have scored marks less than 10? Or how many students have scored marks less than 20? Answering the first question is easy. As we can observe, there are 5 students who scored less than 10 marks. There are 5 students as an answer. But now when it comes to second question, we asked how many students scored less than 20 marks. Is it 3? Maybe not, because students scoring marks between 0 to 10 are also less than 20. So total students will be 5, which are between 0 to 10, plus 3, which are between 10 to 20. So this gives us 5 plus 3, 8 students who have scored marks less than 20. Now the question is, how many students have scored less than 30 marks? It will be 5 plus 3 plus 4, that is 12 students. Or I can say 8 plus 4, that is 12 students. Similarly, we can compute the number of students with marks less than 40, less than 50, less than 60, and less than 70 till less than 100, which is our last class interval. So what is this new column that we have calculated? You can observe that what we have done is we have just added frequencies from the previous class interval to the next class interval. And what do we call this? Yes, you are right. This is nothing but cumulative frequency that we have calculated. Since we have calculated for less than 10, less than 20 or less than marks, this becomes less than type of cumulative frequency distribution table. Yes students, you have correctly heard. This is less than type where 10, 20, 30 are nothing but the upper limits of the given class interval. Now here, 5 is the cumulative frequency of first class, 8 is the cumulative frequency of second class, 12 is the cumulative frequency of third class that we get by adding 8, that is cumulative frequency of upper class, and adding 4 to it, which is a frequency of the present class. And so on, we can calculate cumulative frequencies for each less than class interval. Here students, as you can observe, we started with the first class. We write the first frequency as it is and then cumulate downwards. Thus, this kind of distribution is called the cumulative frequency distribution of less than type. Now the question is how to make cumulative frequency distribution graph or how to represent this table graphically. So let's learn it. Let's see how to draw cumulative frequency distribution graph of less than type. In statistics, such a graphical representation of cumulative frequency table is called cumulative frequency curve or an ogive. The term ogive is derived from the word og. And do you know students what is an og? Actually students, og is a shape of arc that you see on your screen. Such an arc is formed by intersection of two S-shaped curves. This word OG was used or is used very commonly in architecture to describe curves or curved shapes, especially in 14th and 15th century Gothic styles architecture. As you can see, it is nothing but a special type of arc. Now, as we mentioned, it is derived from the architectural word OG. In stats, it is used to represent the graphs that are formed from cumulative frequency distribution table and estimate how many numbers lie below or above a particular value in the data. So let us see steps to make a cumulative frequency distribution graph or Jive? For that, let us consider our same previous example. We will start by constructing the x-axis and y-axis on a graph paper. Next, on x-axis, mark the upper limits of the given class intervals. And on y-axis, mark the cumulative frequencies. Note that here scale cannot be same for both the axes. For x-axis, scale can be 1 cm is equal to 10 units, since difference in upper limits of our class intervals is 10 units. While for y-axis, scale can be 1 cm is equal to 5 units, since our cumulative frequencies range from 5 to 53. Now students, the scale for x-axis and y-axis may vary with each of the example that you are solving. Now plot the points x and y using the upper limits as x and their corresponding cumulative frequency as y. For the first class interval, we have upper limit as 10 and its corresponding cumulative frequency is 5. Hence, we will plot the point 10, 5 on the graph. Similarly, for the next class, the upper limit is 20 and cumulative frequency will be 8. So we will plot 20, 8 on the graph paper. So what will be the next point? Correct, it will be 30, 12. We will plot all the remaining points on the graph paper in the same way. Now join all these points to obtain a smooth freehand curve. And this curve is now known as less than type or Jive. Now as an exercise, students, can you represent this data in the form of less than type or Jive? To make less than type or Jive, as you know, we first require to construct cumulative frequency distribution table, and which can be done as shown on your screen. Now plot the points x and y by taking proper coordinates as upper limits as x coordinate and y coordinate as its cumulative frequency on the graph paper. Join the points using a freehand curve and you will get cumulative frequency or Jive of less than type. Now what about one more type of cumulative frequency distribution and its graphical representation, that is of more than type? We will learn about this in our next video.